Hello friends, today we are going to discuss GATE previous year questions. Just let me know if I'm audible and visible to you. And once you say something hi, hello, or anything, then we will start. So I am just waiting for one comment. Please let me know if I'm audible and visible to you guys. Okay, I got a message from King Rider and he said I am audible and visible. So let's start today's session. So first of all, let me introduce myself. Hi guys, I'm Viomesh Singh from GeeksforGeeks and I'm your mentor for operating system. And we have discussed semaphores in previous video. We have discussed critical section, race condition, and today we are going to solve some gate previous year question based on the semaphore. The gate question based on the semaphore most of the time looks very scary. Fine, but they are very easy to solve. You can solve them very easily. So So let's watch those questions, let's discuss. And in the meantime, if you find any difficulty to understand any question, you just provide me the feedback or comment in the comment section. So let's start now. So first question I'm going to discuss from the 1998. Why I'm discussing this question? Because it is quite easy and it will give you the brief of the counting semaphore. So what is our question? You can read the question first of all. A counting semaphore has initialized to 0. So write s equal to 10. And then 6p operation. P means down or wait operation. So we have 6p operations and 4v operations. So 4v operation. V means signal or up operation. The resulting value of the semaphore is. So it is asking the resulting value when we are performing wait operation, it will decrease the value of semaphore. So with 6p operation, value will be 4. After 6p operation, value will be 4. So now semaphore value is 4 now. But once we apply 4v operation, that means up operation, then value will be s equal to 4 plus 4. So answer should be 8. Final value will be 8. So answer should be B. This was pretty simple question was asked in the 1998. That's why we solved this one very first. So you can understand it. Fine. And as soon as we go further, we will take difficult questions. So next question is also based on the counting semaphore, but it is little bit difficult than the last one. So first read the question. Consider a non-negative counting semaphore S and the operation PS decrement S. So PS is the down operation or wait operation and VS is incrementing S. That means it is up operation or signal operation. During the execution of 20 PS operation means 20 down operation. Fine. And 12 VS operations are issued in some order, in any order we can say. The largest initial value of S for which at least one P operation will remain blocked. So let me tell you what will be the answer. At least one value will be blocked. So let me give you one example. Suppose initially value of S is 1. Fine. If any process want to access a critical section, it will decrement the value of semaphore 1 and go inside the critical section by performing P operation. Suppose one operation comes and it performs PS operation. So P1 is performing PS operation, so value is 0. So that means it is inside in its critical section. And after that new process comes, suppose P2 is coming and it is also performing the operation PS. Fine. So process P2 is performing the PS operation. So I am writing P2 as it's just to a metaphor. Otherwise, it should be written like that. P2 for P2 it is PS, but just to make it easy, I am writing P2S. So when P2 will perform the PS operation, it will decrement the value of 0 because it is counting semaphore. So value will go to the -1 and P2 will go into the blocked state. Fine. P2 is in blocked state or waiting state. And I have told you when I was teaching or when I was discussing the accounting semaphore, what I have told you, the minus value of the semaphore will tell us how many process are in the blocked state. Suppose new process P3 come. P3 come and it is also performing the PS operation. That means it is decrementing or waiting, it perform the wait operation on the semaphore. So value will be -1 to -2, and this operation will also go into the blocked state. Fine. It is also in the blocked state. So suppose there is a queue, blocked queue associated with semaphore. So this is the queue, which consists P2 and P3, two block of process. Fine. So minus value is giving us the total number in the blocked state. Fine. And in our question, it is given at least one operation will remain in the blocked state. That means semaphore final value must be -1. The semaphore minus value must be -1. So if let me first delete everything. So I have told you that negative value of the semaphore uh, provided the information that what should be the how many process are in the blocked state. So we don't know initial value of the S, but what we know after the P and V operation. So what will be the operation? S plus P operations and V operation value should be -1. Value should be -1. So how many P operations are there? 20. How many V operations are there? 12. And value is -1. So let me write it here S. So S is S plus 8 equal to -1. So S will be, sorry, I have written wrong somewhere. So let me write it again. What I have, what mistake I made, I used plus here. Fine. But P is decrementing the value. So it should be minus. So let me write it again. So negative value of semaphore provide us the information that how many process are in the blocked state. And in our question, it is given at least one operation will remain blocked. That means value of S must be -1 at the end. So let me write S plus P operation. It is not plus, it should be minus because P is decrementing the value of the semaphore and V is incrementing because it is the signal or up operation should be minus. So we don't know the value of initial value of the S, but we know how many P operations are there, 20. So it is S minus 20. And after that, 12 V operation, it can be in any combination, right? So this is plus 12. And now total value should be -1. So S minus 8 equal to -1. So S value should be -1 plus 8, which is 7. So answer should be 7 here. I hope you understood the question. And still, if you are facing any problem, just let me know in the live chat and I will provide you the explanation again. So, guys, there is no message in the live chat. So, I'm going to discuss scary questions now. Fine. And in 2003, there was a combination of the question. That means two questions can be connected or on the same concept. So there are two questions. You can see these are the two questions based on same topic of the semaphore or same initial problem. So let's discuss first question. Suppose we want to synchronize two process P and Q using binary semaphore. Now we are going to talk about binary semaphore. We have two value S and T. The code for the process PQ is shown below. This is the code. You can see this is the code. And we have WXYZ. And what is that? Let me tell you. Synchronization statement. Synchronization statement means WXYZ could be either wait operation or signal operation on semaphore SMT. Fine. So WXYZ can be wait or signal operation upon S and T semaphore. Which of the following will lead to an output starting with 0011 0011 0011? Fine. Now you can see if process P performs first. If process P performs first, we will get the output 00. And if process Q is performing, we will get the output 11. So if we want this sequence 0011 0011, then 0011, that means P first P should perform, then Q, then P, then Q, then P, then Q. It should be performed like this. To perform P, we should apply W operation and then X operation. After completion of uh, process P, we should perform X. That means signaling something. Now, suppose I am taking S equal to 1 and T equal to 1. Suppose I am taking both the semaphore 1. Fine. So what will happen if both are 1? Then in that case, process Q might decrement or might perform the wait operation on the T and wait operation on the signal. Suppose here for the Q, I am using T, and for the process P, I am using semaphore S. Fine. Suppose S and T both are 1, and process Q will perform wait T operation and earlier than process P. Then 1 will be printed earlier. So this cannot be the answer. Fine. Anyhow, we need to perform P operation. That means first statement should be W. Fine. First statement should be W, then X, then Y, then Z. So let's read the options A, B, C, D. So what are the options? PS perform the W. In all the cases, PS is performing the W. That's fine. Then VS. That means signaling the S. So that means process P is performing, or we can say process PS. If process P is performing on semaphore S, it is decrementing the semaphore S. Fine. So to print this, we need to decrement S. So to print 00, we need to decrement uh, S semaphore. And to print 11, we need to decrement semaphore T. Now here you can see P must be implemented before Q. And after P, only Q can be implemented. Process Q can be implemented. So what is my suggestion here? Once process P is implemented its critical section, that means one process P decrement the value of S and print the value of 00. After that, it will it will signal the value of T. Why so? Initially, we have seen if both value are 1, 1. If both value are 1, 1, then in that case, we cannot guarantee that 00 will be printed. It can be printed 1, 1. It can be printed 1, 0. It can be printed 0, 1 based on the critical section. Fine. So that is the problem here. So initially, T must be 0 and S must be 1. So T must be initially 0. So that's I crack it because I need that sequence. So let's see where it is. So A cannot be the answer, and B can be the answer, as well as D can be the answer. Fine. A and C cannot be the answer because we want this sequence. Now both are operating P, S, and W. That's fine. And then we can perform. Both are operating. One is performing BT operation process. Option B is performing signal of VT. And after the signal of VT, then only Q can perform uh, uh, wait operation on T. So it should be up by process P, then only Q can be implemented, or then only process Q can decrement the semaphore T. So I got one comment from King Rider. Sir, please can you repeat? Uh, can you please tell me which question you want to repeat and from where you want me to repeat? I am waiting for your comment. Okay, so King Rider asked me to explain this question again. So I am going to explain this question from very starting. So I hope this will be simple for you then. So let's remove everything and let me repeat everything. Fine. So, okay. Okay. So let me tell you the question first. King Rider, please listen carefully now. And we have two process P and Q using binary semaphore S and T. The code for the process is given below. So P is printing 00 by performing W and S. W is the down, W is using for the down, and X is for the signal. And what is signaling? Either S or T, we don't know yet. Fine. In process Q, also perform Y operation. It should be a down operation, or we can say P operation. And once it is done, it will perform V operation or signal operation. So that's we already know because we know what is semaphore. Now we need to know what is WXYZ. First of all, we need to find out what is WXYZ, which is the P operation, which is the V operation. That is the question. And we need to print 0011 0011. So let me write 0011 0011 0011. So for to print 00, process P need to be implemented first. So that means P is implemented first. For double one, Q is implemented. For double zero, P is implemented again. For double one, that is Q is implemented. Then P is implemented. Then Q. If you have studied strict alteration method, find or turn variable, you can recall this because you can see it is strict alteration. P Q P Q P Q. Right. So I hope you can relate it because it is the problem of strict alteration of critical section problem, but it is solving it by the semaphore. So let me tell you how it is happen. So to perform P, first P will perform weight operation, and in all the symbols you can see A, B, C, D. P is performing first statement is S is decremented as on semaphore S down operation is implemented. So value of S must be 1. Fine. Then only P can perform W and or weight operation, and after that it will print 00. So W is for P of S. That is false here. W is for P of S. In all the options, it is P of S. So that's fine. Suppose initially T is also 1. Suppose initially T is also 1. So what can happen? Y is here you can see Y is also P of T. So Y is P of T. So let me write Y is P of T. So that is very much clear. In all the options, uh, W is P of S and Y is P of T. It is given. You can see here. Fine. So that is clear in any case. Now, suppose initially both are 1. S and T both are 1. What happens if S and T both are 1? Then process Q can be implemented before P. Right? If process Q is performing before P, that means 1 will be printed before P. So that can be case. That can be the case. Fine. So it should not be the case because we need 00. In anyhow, we need 00. So whenever in any option where initial value of t is 1, it is automatically eliminated. T cannot be 1 initially. T cannot be 1 initially. If T is already 1, that means P and Q, process P and Q both are competing with each other to enter their critical section. Maybe process Q can enter their critical section and it will print 1 1 before P. So that should not be the case. So answer, so option A and C are eliminated. Fine, because initial value of T should be 0. Now let's see how it happened. Now let me initialize T to 0. So value of T must be 0. Fine. Now if you can see P of S, the P of S is performed as W. So process P is performing P of S. That's fine. So let me write here. P is performing P of S. When it performed, value of S is 0. And after that, it is printing 0 and 0. So 0 0 is printed here. This first line is printed. And after that, I have told you it is strict alteration method. It is strict alteration or done variable. That means after P, you can see Q must be performed. To perform Q, value of the semaphore T must be incremented. Value of the semaphore T must be incremented. So this is the W is P of S. Then X should be incrementing the value of T. Then only Q will be implemented. Process Q can be implemented once semaphore T will be incremented or it can perform signal operation. So V of T must be here. V of T must be here. And after that, once we are changing the value of semaphore T from 0 to 1, then only it can perform line Y, which is P of T. Sorry, I have written here as it is T. So then only it can perform T. And after that, it will print 1 1. So 1 1 is printed. And after that, after printing 1 1, process P must be get the CPU, or process P must print 0 0. That means it will increment the semaphore which is accessed by the process P. So it will so with Z line, it what will it do? It will signal semaphore S. So this would be the answer. You can see VT is X. So at X we are signaling T. Yes, at X we are signaling T. So answer is B. You can see these two are common in all the cases. That means W and Y are common. And I have already told you 1 1 initial value of T cannot be 1. Now remaining options can be B and D. In B, you can see after P of S, it is performing V of S. Fine. After P of S, it is performing V of S. But it cannot be how it happen, because first we need to increment the value of T semaphore. And if we are not incrementing the value of the semaphore, so you can see before decrementing, how can we perform the P semaphore? Because value is already 0. I have told you value of T cannot be 1. So I hope you understood my point. So answer is B here. Answer is B here. So that was the scary question, because it is lengthy. It is lengthy, no doubt. But if you have studied strict alteration method, if you have gone through my previous video, that is 1 minute question, hardly 1 minute, because we know first P need to be performed, so semaphore must be decremented. After that only Q can be performed. So that means value of the semaphore, which is uh, T, here you can see Y is T, so it should be incremented by P, and on strict alteration, the value of the semaphore S, which is down by process P, must be incremented by process Q. So that is strict alteration. Yes, Jaya Dubey, answer is P. So I hope you understood this question.